We previously have discussed how to run an ANOVA table when considering just one factor. For example, how practice time related to swim times. Now we're going to look at two factors and also consider the interaction between factors. What we have here is a data set that presents gender, 1 for males, 2 for females, caffeine consumption, how many cups of coffee they consume a day, and stress levels. Participants were asked to self-rate their stress on a scale of 1 to 3. Now we want to look and see, does gender relate to caffeine consumption? Does stress relate to caffeine consumption? But we also want to consider the interaction between the two. Do females tend to get more stressed and therefore drink more coffee, where males might handle stress a different way and not turn to caffeine? So it's important not only to consider the gender difference and the stress level difference separately, but to consider how the two factors interact. We're going to do this in SPSS by choosing the Analyze option, the General Linear Model, and we're going to perform a univariate analysis. Once we have done this, we will go ahead and choose our values. The dependent variable is what we think is changing. We think caffeine consumption is changing or related to gender and stress. Okay? Fixed factors in this case are stress levels. The stress level is something that changes, but it is not random. Random factors are gender. We cannot change gender, and your gender does not change day to day. Your stress level may change day to day, but the random factors are set randomly. They cannot be altered, and that would be gender. I am also going to choose a few options. So I'm going to choose the options menu, and I am going to ask SPSS to create the descriptive statistics, much like we did before, in order to compare the different groups at the end. We will then hit Continue and OK to allow SPSS to do its thing. Once SPSS has run the calculations, we have a summary table that just outlines how many people fell into each category. This is our descriptive statistics, or it gives us the mean for males who reported low stress and females, as well as overall. Males who reported moderate and females who reported moderate, as well as overall. And then males and females who reported high stress and overall. And then they looked at overall caffeine consumption, not related to stress level, just males and females and overall. Let's take a look at the analysis portion, the good stuff. This looks at determining which were significant. We have the stress, the gender, and the stress star gender indicates the interaction stress and gender. When you look at the significance levels, you can determine which factors were statistically significant. Remember, you're looking for values less than our alpha level of 0.05. Well, stress is greater than 0.05. Therefore, it cannot be shown to have an effect on caffeine consumption. But gender is 0.04, less than 0.05. This is statistically significant. It would be related to caffeine consumption. Next, we have the interaction effect between stress and gender, 0.923, greater than our alpha level, and therefore not statistically significant. Once you determine which are statistically significant, you can go up and determine how they are changing. Now, we do not have the skills at this point to run an actual statistical analysis, and say for certain that females statistically do drink more coffee than males, but we can do a little post-analysis looking and determine it's very likely, since females are sitting at 6.36 cups of coffee, that they are consuming more coffee than males on average. So we can analyze that way and look at those descriptive statistics to determine where you might fall. For example, if you were a female, like myself, and you were saying, I have moderate stress, you might look at that and compare and say, well, I'm going to drink on average maybe 6 cups of coffee, as opposed to the male with 5.38. So looking at these descriptive statistics cannot statistically support anything formal, but it can give us a good idea of where people fall in general. In higher level stats classes, you would learn how to support this with significance levels, much like we did below